Good morning, everyone. In the last class, we learned about the point form of Ohm's law, that is J equal to sigma E. How we obtained the derivation is very important. If you go for objective questions or 2 marks questions, it will ask J equal to sigma E. How we have to derive? It is also the sigma, where sigma is known as 1 by rho, that is reciprocal of resistivity, sigma is known as. Now we go for another topic, properties of conductor under electric field. When a conductor is subjected to electric field, suppose the electric field is passing, when conductor is placed inside of the electric field, what is the behavior? After that we go for dielectric. When a dielectric is subjected to electric field, if it is a dielectric, when it is subjected to electric field, how it behaves. Next, between two conductors and dielectric, what is the boundary condition? It acts as capacitor if a conductor, and insulator is provided. If you provide another plate, if you provide, then it acts as capacitor. The capacitor principle, capacitors in series, capacitor in parallel. And polarization, dipole per unit volume, dipole moment. You know not what is dipole. When the two charges are separated by positive and negative, separated with a small distance, then it is called dipole moment. Dipole moment M equal to any one of the charge Q into distance of separation, that is dipole moment. Now we go for all these topics in depth, that is conductors and dielectrics chapter. Now we go for behavior of conductor in electric field. How the conductor behaves in electric field when it is electric field E bar is subjected to a conductor. If you know the properties of electric field and conductor properties, then you can easily understand. When the charge distribution, suppose if it is a conductor, when the charge distribution suddenly unbalanced inside of the conductor, there are number of electrons trying to reside inside the conductor. All the electrons are negatively charged and they start repelling each other, because if you consider the conductor, when it is suddenly unbalanced, the charge distribution inside of the charge, and they start repelling each other, because first negatively charged electron, it is also negatively charged electron, they will start repelling each other due to their own electric fields already. If you subject an electric field E bar, then what is the behavior? First we have to know properties of conductor. Such electrons get accelerated away from each other till all electrons causing interior imbalance reach at the surface of the conductor. All the electrons will reach to surface of the conductor. The conductor is surrounded by the insulating medium, and hence electrons just driven from the interior of the conductor. Under static conditions, the first one is, under static condition, no charge, no electric field can exist inside of conductor. No charge, no electric field under static conditions. The charge can exist on the surface of the conductor, giving rise to surface charge density. If you go for conductor, skin effect all will be there. On surface of the conductor only, the charge will be distributed. If the charge exists on the surface of the conductor, gives rise to surface charge density. That is also one of the property of conductor. Gives rise to surface charge density. And one more thing, the another property of conductor is, if the charge distribution on the surface depends on shape of the surface. The charge distribution depends on the shape of the surface. The conductivity of ideal conductor is infinite. Ideal conductor means the resistance is 0 for ideal conductor. Hence the conductivity of an ideal conductor is infinite. The conductor surface is an equipotential surface. Another property of conductor is, the conductor surface is equipotential surface. Equipotential surface, what is the potential difference between any 2 points on the conductor is 0. Equipotential surfaces. Conductor, if you consider the conductor, this conductor, if you consider any point on this conductor, potential ఇక్కడ ఉండే పాయింట్ ఈక్వల్ V1 equal to V2. Then any conductor surface acts as equipotential surface. The potential difference between 2 points is 0. These are the properties of conductor. After that we go for how the conductor behaves when it is subjected to electric field. When external electric field, not internal electric field, already conductor have internal electric field. When it is subjected to electric field externally applied to a కండక్టర్లో ఏముంటాయి, ఆల్రెడీ ఫ్రీ ఎలక్ట్రాన్స్ ఉంటాయి, ఆల్రెడీ ఫ్రీ వేలెన్స్ ఎలక్ట్రాన్స్ ఉంటాయి కదా. ప్రజెంట్ ఇన్ ద కండక్టర్ స్టార్ట్స్ మూవింగ్, దట్ ఈస్ ద ఇంపాక్ట్ వెన్ ఎక్స్టర్నల్ ఎలక్ట్రిక్ ఫీల్డ్ ఈజ్ సబ్జెక్టెడ్. When external field is applied to conductor, the free electrons present in the conductor starts moving and adjusted in adjacent atoms. When electrons are moving, they attain constant average velocity called drift velocity. What is meant by drift velocity? When the electrons are moving, they attain some constant average velocity. That is known as Vd. Drift velocity it is denoted by. The drift velocity proportional to applied electric field. Whenever you applied electric field, the free electrons inside of the orbit, of the outermost orbit లో ఉండేవి కదా ఫ్రీ ఎలక్ట్రాన్స్, అవి మూవ్ అవుతాయి అంటే విత్ యావరేజ్ వెలాసిటీ దట్ ఈస్ ప్రపోర్షనల్ టు ఎలక్ట్రిక్ ఫీల్డ్. Vd is proportional to electric field and Vd equal to minus mu e, where mu is called mobility of free electrons, where mu is called as mobility of free electrons. The relation between drift velocity and electric field is proportional. This we have to remember. Mu is called mobility of free electrons. Mobility of free electrons it is. That is the behavior of conductor in electric field. Already conductor have some electrons inside of the conductor. Those will starts moving due to applied electric field, and they will adjusted in adjacent atoms. When the electrons are moving, they attain constant velocity is called drift velocity. That we have to remember. Vd is proportional to E, applied electric field E bar, Vd, where mu is called, if you remove the proportionality, minus mu E it is. Why we represented minus mu E it is? When the electrons moving, the loss of charge, loss of velocity, loss of charge, that is minus mu we indicated. Why the negative sign is indicates that electrons are moving against the direction of E bar, against the direction of E bar, hence we are writing the negative E. Vd is proportional to mu, Vd equal to minus mu E. These are moving against the electric field, hence we are writing minus mu E. Now properties of conductor in electric field are the electric field inside of a conductor is 0. That we have to remember. The various properties of conductor in electric field is, first one is electric field inside of any conductor is 0, and the charge of inside of any conductor also 0. If it is a conductor, then the total electric field, total charge will not be inside of the conductor, it will appear surface of the conductor. The electric field E bar inside of a conductor is 0, the charge of inside of any conductor is 0, and it is accumulated surface of the conductor. That's why it is called skin effect in case of AC. The conductor surface is equipotential surface. These are the 3 points already we discussed. Remember this. Okay, first now behavior of dielectric in electric field. How the dielectric material, when dielectric material is subjected to electric field, how it behaves. Similarly కండక్టర్లో ఏం జరుగుతుంది, ఎలక్ట్రాన్స్ సమ్ అటైన్ అవుతాయి, Vd సమ్ యావరేజ్ వెలాసిటీతో మూవ్ అవుతాయి ఎలక్ట్రాన్స్. ద డ్రిఫ్ట్ వెలాసిటీ ఈజ్ ప్రపోర్షనల్ టు ఎలక్ట్రిక్ ఫీల్డ్ E bar, and if you remove the proportionality, it is Vd equal to minus mu E. That is the property of electric field, property of conductor under electric field. Now we go for behavior of conductor, behavior of dielectric. Dielectric means insulator. The valence electrons inside of insulator is very less. Okay, for example, air have dielectric is 30 kilovolts per centimeter. dielectric strength of air. 30 kilovolts if you apply between two metal electrodes. These are the two metal electrodes. If you apply, it is a air, assume that inside between two metal electrodes. If you apply the 30 kilovolts between two and the distance between two electrodes is 1 centimeter, then the air acts as conductor. An arc will exist. That is the dielectric strength. How to find? By using air dielectric strength is 30 kilovolts per centimeter. టూ ఎలక్ట్రోడ్స్ 1 సెంటీమీటర్ దూరంలో పెట్టినప్పుడు ఒక ఎయిర్ ఉన్నప్పుడు మనం 30 కిలోవాల్స్ అప్లై చేసామనుకోండి ఇక్కడ టూ ఎలక్ట్రోడ్స్కి, ఇట్ యాక్ట్స్ as కండక్టర్. ఆర్క్ ఈజ్ ఎగ్జిస్ట్ బిట్వీన్ టూ కండక్టర్స్. That is the dielectric strength. Dielectric strength, that is dielectric is the insulator dielectrics are the insulators whose behavior can be modified in the electric field. If you apply the electric field, then the dielectric behavior can be changed. The main difference between conductor and dielectric is availability of free electrons. Already we told that. In the outermost orbit to conduct current. Due to free electrons only, the conductor carries the current. Conduct the current. The conductors have large number of free electrons, whereas insulators have less number of free electrons. The atom of dielectric consists of a positive nucleus. If you go for atom construction, atomic structure of a dielectric, the atomic structure of a dielectric consists of a positive nucleus and electron cloud. Electron cloud will be in different orbits as shown in figure. It is a positive nucleus and electron cloud totally. The electrons are bounded charges by the finite forces and they are not contribute in the electric field in the conduction of current. The electrons are the bounded charges. They are bounded with certain finite forces. డైఎలక్ట్రిక్లో ఎలక్ట్రాన్స్ ఫ్రీగా మూవ్ కాలేవు కూడా. ఎందుకంటే మనం ఎక్స్టర్నల్ ఫీల్డ్ అప్లై చేస్తే ఈ ఎలక్ట్రాన్స్ మూవ్ అవుతాయి. అప్పుడు సమ్టైమ్స్ ఇఫ్ యూ ఇంక్రీజ్ ద ఎక్స్టర్నల్ ఎలక్ట్రిక్ ఫీల్డ్, ఇట్ యాక్ట్స్ యాజ్ కండక్టర్. డైఎలక్ట్రిక్ అంటే బిహేవియర్ చేంజ్ చేసుకోవచ్చు. కండక్టర్ డైఎలక్ట్రిక్ యొక్క బిహేవియర్ వీ కెన్ ఆల్టర్. ద ఎలక్ట్రాన్స్ ఆర్ బౌండెడ్ చార్జెస్ బై ఫినైట్ ఫోర్సెస్ అండ్ దే ఆర్ నాట్ కంట్రిబ్యూట్ ఇన్ కండక్షన్. That is the property of dielectric medium. How the dielectric is made with number of electrons? No, it is made with less number of electrons. The bounded forces are there. All the electrons which are there in orbits, they are not contribute in conduction. This is about the behavior of dielectric in electric field. Again we go for in polarization and dipole moment. Suppose these two charges are movement happen. మనం ఎక్స్టర్నల్ ఎలక్ట్రిక్ ఫీల్డ్ అప్లై చేసామనుకోండి, ఈ చార్జెస్ మూవ్ అవుతాయి కదా, డైపోల్ మూమెంట్ క్రియేట్ అవుతుంది డైఎలక్ట్రిక్లో. డైపోల్ మూమెంట్ అంటే ఏంటంటే ఫస్ట్ యూనిట్లో మీకు ఆల్రెడీ ఎండింగ్లో వచ్చింది. డైపోల్ మూమెంట్, డైపోల్ అంటే ఏంటి, వై ద డైపోల్స్ ఆర్ ఫార్మ్డ్ అనేది ఇక్కడ వస్తుంది. దట్ ఈస్ అబౌట్ డైఎలక్ట్రిక్. ఆల్రెడీ కండక్షన్ will not be happen when electric field subjected. When electric field E bar is applied to dielectric material, the electrons and nucleus shifted to their positions against atomic forces. When electric field E bar is applied, that is important. Electrons and nucleus shifted their positions. The shifting of relative positions of bounded charges allows to store electrical energy. That is the important thing. The capacitor stores the energy in the form of electric field. Why? Because the capacitor is made with two plates. Between two plates, if you provide dielectric medium, the capacitor stores the energy in the electric field. Electric field is there inside of the dielectric medium. The shifting of relative positions, when you apply the voltage for plates of a capacitor, the dielectric nucleus and electrons shifted inside of that dielectric. The shifting of relative positions of bounded charges allows to store the electrical energy in the dielectric. That's why capacitor stores the energy. What is the energy stored in capacitor? 1/2 CV square. The shifting of relative positions of bounded charges allows to store the electric energy. That is the important thing. Now we go for polarization. What is the behavior how the dielectric medium behaves when electric field subjected. The electrons inside of any dielectric will move atomic forces, bounded forcesతో ఉంటాయి కదా. ఎప్పుడైతే మనం ఎలక్ట్రిక్ ఫీల్డ్ అప్లై చేసామో ఈ బౌండెడ్ ఫోర్సెస్తో ఉండే ఎలక్ట్రాన్స్ మూవ్ అవుతాయి, షిఫ్ట్ అవుతాయి, అప్పుడు ఎనర్జీ స్టోర్ చేసుకుంటుంది. నౌ వి గో ఫర్ పోలరైజేషన్. You can see how the dielectric behaves when external field subjected. Polarization will happen. The electron cloud will be changes their position. Nucleus also shift their position. Electron, this is electron. This is the dielectric properties. Dielectric when it is subjected to external electric field. Now we go for polarization. The polarization is important topic in engineering electromagnetics or EMF. The polarization means it is the process of separation between nucleus and electron cloud. Already the nucleus and electron cloud is separated and they will change the position, relative position, that is known as polarization. Or simply the electrons will move and with a small distance, the dipole moment per unit volume is called polarization. It is the positive nucleus, it is electron. There is a small distance of separation, that is how the electron is moving. Dipole moment per unit volume is called polarization. Okay, that is the polarization. When electric field E bar is applied, the positive charge experiences a force. The positive charge is in nucleus that experiences a force that is given by F equal to QE. F equal to QE. While negative charge expresses force F equal to minus QE in opposite direction. While negative charge experiences a force, suppose if it is electron, the electron experiences a force we can represent as negative in opposite direction. F equal to minus QE. If the electron is experiences a force, that is F equal to minus QE. Then there is a separation between nucleus and center of the electron cloud. Already we saw that when subjected to electric field, when the electric field is applied to dielectric material, the electrons and nucleus shifted their positions. Already we saw that. Is understand that? Now there is a separation between nucleus and center of the electron cloud, like this in this diagram. Such an atom is called polarized atom. Such an atom is known as polarized atom. This forms an electric dipole. The equivalent dipole formed, you can see in this, positive charge is the nucleus and negative charge a small distance d. That is a negative charge minus q and positive charge plus q, a small difference, and the electric field is applied for this. Okay, it can be seen that electron cloud has centered, separated from the nucleus. This forms an electric dipole. The equivalent dipole formed, you can see in this diagram. The dipole gets aligned with the applied electric field. This process is called polarization of dielectric. There are two types of dielectrics. One is non-polar dielectric and polar dielectrics. Non-polar and polar, two types are there. But what is meant by polarization? The process of separation of between nucleus and electron cloud is known as polarization. It is also known as dipole moment per unit volume. That is the polarization. It is very important definition for you. We have to remember polarization. The another important factor is expression for polarization. How to express the polarization in the express form, in the equation form. The dipole moment per unit volume is known as polarization. Already we know that. While it's happening, n number of dipoles are formed. When electric field is subjected, dipoles will be moved, dipoles will be formed, number of dipoles will be formed. The dipole moment m equal to QE, already we know that the product of any one of the charge into distance. The charges are positive and negative charges between separated with a small distance, it is called dipole. Dipole moment m, or another, what is another letter? M is P bar also. Dipole moment m bar equal to Q into D, or P bar equal to mq into d. where q is the magnitude of any one of the charge and d is the distance of separation, positive and negative charges. Now the total dipole moment is obtained by using superposition principle. Now total dipole moment m total equal to total dipole moment. The total dipole moment obtained inside of the conductor due to electric field E bar is given by q1 d1 plus q2 d2 plus qn dn. What is dipole moment? You know that, q into d. If the number of dipoles are formed, because the dielectric is subjected to electric field, number of dipoles will be formed. Therefore polarization P equal to limit delta V tends to 0 q1 d1 plus q2 d2 plus and so on qn dn divided by delta V. Polarization P bar or m bar equal to limit delta V tends to 0 summation. By the use of summation we can represent like this: summation I equal to 1 to n qi di by delta V, coulomb per meter. Q charge is in coulomb, distance is in meter, and delta V volume is meter cube. Now polarization units are coulomb per meter square. The units of polarization is coulomb per meter square. Coulomb per meter square is also unit for electric field flux density. First unit we know that electric flux density is charge per unit area is known as electric flux density. Electric flux per unit area is also called as electric flux density. Thus polarization increases the electric flux density in electric medium. Electric flux density increases in polarization. What is? Are you understand this expression for polarization? Very simple. What is the expression for polarization is dipole moment per unit volume is known as polarization. Similarly, number of dipoles are formed. Number of dipoles divided by total volume or small volume we consider delta V. Then limit delta V tends to 0. Summation I equal to 1 to n qi di by delta V. That is the polarization per unit volume. The unit for polarization is coulomb per meter square. మనకు ఆల్రెడీ తెలుసు కదా, పోలరైజేషన్ యూనిట్ ఈజ్ సేమ్ యాజ్ ఎలక్ట్రిక్ ఫ్లక్స్ డెన్సిటీ. దస్ పోలరైజేషన్ ఇంక్రీజెస్ ద ఫ్లక్స్ డెన్సిటీ అని చెప్పాం ఇన్ ఎ డైఎలక్ట్రిక్ మీడియం. హెన్స్ వీ కెన్ రైట్ ఎలక్ట్రిక్ ఫ్లక్స్ డెన్సిటీ d bar can be represented as d equal to epsilon e, that we know the relation d equal to epsilon e. D equal to epsilon e, we know the relation, but plus p polarization it is known as. For isotropic or linear medium, the p and e are parallel to each other at every point and related to each other. P equal to psi epsilon naught e bar. Okay, electric flux density d bar can be written as epsilon e. D bar equal to epsilon naught e or epsilon e plus polarization we have to add. Electric flux density unit also it is. Polarization we can add for electric flux density. It can be seen that the units of polarization and the flux density, electric flux density d bar is both are same. For isotropic and linear medium, the polarization p bar equal to psi, it is known as chi it is epsilon naught e. Substitute equation 2 in this equation. If you substitute, the equation 1 can be written as d equal to epsilon naught e plus p bar can be written as chi into epsilon naught e. D bar equal to epsilon naught e plus into 1 plus psi e. Here 1 plus psi e is known as relative permittivity. 1 plus psi e. We can write d bar equal to epsilon r e. Make it as equation number 3, where psi is electrical susceptibility. It is known as susceptibility, where epsilon is known as permittivity of dielectric, where psi is known as electric susceptibility. For air, epsilon r equal to 1 and air psi equal to 0. Hence we can write 1 plus psi e equal to 1 plus 0 equal to 1 plus 0 equal to 1 we can write. Similarly, you are understand this, epsilon r equal to 1 plus psi For air, epsilon r equal to 1, how we are obtaining? Relative permittivity of air is 1. For air, the electrical susceptibility is 0, hence epsilon r equal to 1. If you substitute in place of 0 here, then you can get epsilon r equal to 1. Therefore, the equation 3 can be written as d equal to epsilon e. D equal to epsilon e. This is the main polarization equation we can write as P equal to psi e epsilon naught e bar also, and simply for depends on number of marks they allotted the question, or the number of marks they are allotted the question, we have to write. Express the polarization in detail means we have to write all entire properties of dielectric material. Already we know that the various properties of dielectric material under influence of electric field. Already we know that properties. Let us see simply. The polarization increases the electric flux density in the dielectric material, and electric field inside outside of the dielectric gets modified due to formation of dipoles. That is the properties. It relates to capacitor and capacitance. When capacitor and capacitance we can use. అంటే టూ ప్లేట్స్ మధ్య కెపాసిటర్ ఇన్ డైఎలక్ట్రిక్ పెడితే కెపాసిటర్ అవుతుంది. అంటే డైఎలక్ట్రిక్ స్టోర్ చేసుకుంటుంది కాబట్టి కెపాసిటర్ స్టోర్స్ ద ఎనర్జీ ఇన్ ద ఫార్మ్ ఆఫ్ ఎలక్ట్రిక్ ఫీల్డ్. టూ ప్లేట్స్ మధ్య మనం ఛార్జ్ పెడితే కెపాసిటర్, వెన్ ద ఛార్జ్ ఈజ్ అప్లైడ్ బిట్వీన్ టూ ప్లేట్స్, ద ఎనర్జీ విల్ బి స్టోర్డ్ ఇన్ డైఎలక్ట్రిక్ మీడియం. డైఎలక్ట్రిక్ మీడియంలో ఎనర్జీ స్టోర్ అవుతుంది. దానివల్ల మన కెపాసిటెన్స్ ఇట్ ఈస్ వెరీ సింపుల్. ఆల్రెడీ యూ నో దట్ capacitor, what is capacitor, what is a parallel plate capacitor, what is the capacitance of parallel plate capacitor. Let us see capacitor and capacitance. మీకు ఆల్రెడీ తెలుసు కాబట్టి ఫాస్ట్గా వెళ్తాం ఇది. వెన్ టూ parallel plates are separated with a dielectric medium it is acts as capacitor. Capacitor is a device used to store electric charge in the form of electric field. That we have to remember. Capacitor used to store the electric field in the form of electric field, whereas inductor, it stores the energy in the form of magnetic field. Consider two plates M1 and M2, positive charge M1 and negative charge M2. It carries equal magnitude as shown in figure. Dielectric medium మనం ప్లేస్ చేసాం అనుకోండి. ఇక్కడ dielectric medium if you place, the capacitor produces the capacitance. Capacitance is given by the equation C equal to Q by B. Already you know, hence we go for very fastly. మనం ఫాస్ట్గా వెళ్దాం. Now capacitance C equal to Q by V కదా. Q ఏమని రాయొచ్చు మనం, surface integral d dot ds according to Gauss law we can write surface integral d dot ds. V ని ఎలా రాయొచ్చు, what is the V and E dot dl, line integral E dot dl. ఫస్ట్ చాప్టర్లో మనకు వచ్చింది ఇది. The capacitors are connected in series. If the capacitors are connected in series, the formula is 1 by C equivalent equal to 1 by C1 plus C2. Why we are obtaining this? Already you know that when capacitors are connected in series, this is the capacitance, because in series voltage is the algebraic sum, hence we are obtain C equivalent equal to 1 by C equivalent equal to C1 plus C2. If the charges are capacitor, how we obtain C equivalent equal to C1 plus C2, C equal to Q by V, C equal to C1 plus C2 plus C3, we can write Q by V as Q by V1 plus Q2 by V2. ప్యారలల్ ప్లేట్ కెపాసిటర్ సిరీస్లో పెడితే ఏమవుతుంది, ఎలా వస్తుంది ఫార్ములా, C equal to Q by V అని రాయొచ్చు మనం. అంటే potential is different but charge will be same in series, hence C equal to C1 plus C2 plus C3. Capacitance in parallel plate, a parallel plate capacitor parallel ఉంటే ఏమవుతుంది, యాడ్ అవుతాయి. Capacitor, if they are connected in parallel instead of series, the capacitance will increase. When capacitors connected in series, the capacitance will decrease. If the parallel plate capacitor, the capacitance will be C1 plus C2 plus C3. If the capacitors are connected in parallel, it is the formula. If the capacitors are connected in series, it is the formula. Already you know that, already studied in networks or electrical technology. Capacitance of parallel plate capacitor, what is the formula? C equal to epsilon naught A by D. That is the formula. Already somewhere you derived. Two parallel plate capacitors ఇలా తీసుకుంటే పాజిటివ్ చార్జ్ నెగిటివ్ చార్జ్, let epsilon naught is the permittivity of the medium, it is the dielectric. Next, let rho s is the surface charge density, electric flux density D equal to Q by A. That already you know that. Now parallel plate capacitor, capacitance and capacitance C equal to epsilon A by D ఎలా వస్తుందో చూడండి. Since D equal to epsilon E, you know the relation between C and D and E, D equal to epsilon E. Electric field intensity E bar can be written as EFI can be written as D by epsilon naught. D equal to Q by A in AZ direction. Assume that my negative of Z axis, the two parallel plates are there in negative of Z axis. We can write Q by A minus AZ. It is a AZ axis minus AZ axis. Z axis negative లో ఉందనుకుంటే parallel plates downward. Now potential V equal to minus line integral E dot dl, we can write V equal to minus line integral D by epsilon naught dl. According to this equation we are substituted. V equal to minus L Q by A epsilon minus AZ dl, we can write. Now V equal to line integral minus line integral Q by epsilon A by Q by epsilon naught A minus AZ dl. dl equal to dz in z direction. We can substitute in place of AZ dz, we can write dz. Finally V equal to line integral Q by epsilon naught A dz. If you apply the integration of z is 0 to d, if you apply V equal to Q by epsilon naught A, that leads to V equal to Q by epsilon naught 0 minus d. 0 to d length is, because the separation of the plate is 0 to d is the separation. Therefore V equal to Qd by epsilon naught A, or we can write Qd by epsilon naught A. Simply d is the distance of separation, or Qd. Now we know the formula. We know the formula of capacitance. Capacitance C equal to Q by V. If you substitute in capacitance C equal to Q by V, Q get cancelled, then C equal to epsilon naught A by D will obtain. Q by V, Q by V, if you substitute V is Qd by epsilon naught A. Q get cancelled, then epsilon naught A by D will be the formula for parallel plate capacitor. Capacitance of parallel plate capacitor. A composite capacitor having dielectric medium, if the relative permittivity epsilon r1, epsilon r2 different relative permittivities are there, then what is the composite capacitors having dielectric medium between two electrics? To epsilon r1 is the one dielectric medium, another dielectric medium is epsilon r. Then what is the capacitance of parallel plate capacitor having different mediums? Different mediums ఉన్నాయనుకోండి ఇక్కడ, అప్పుడు ఎలా ఉంటుంది? ఎప్సిలాన్ r1 ఎప్సిలాన్ r2. ఈ ఎప్సిలాన్ నాట్ ఈక్వల్ టు ఎప్సిలాన్ r. The same formula we applied parallel plate capacitor formula for this also. The total electric potential again for this also, because two electric mediums epsilon r1 epsilon r2 we applied. Similarly parallel plate capacitor. After that we obtained for n number of plates, for n number of mediums, for n number of mediums C equal to epsilon naught A by d1 by epsilon r1 d2 by epsilon r2 plus and so on dn by epsilon r. మామూలుగా ఏమొచ్చింది? C equal to epsilon naught A by d వచ్చింది. అలాగే డిఫరెంట్ డైఎలక్ట్రిక్ మీడియమ్స్ ఉంటే ఏమవుతుంది? A by epsilon naught divided by d1 by epsilon r1. That we have to remember. C equal to A epsilon naught A by d1 by epsilon r1 plus d2 by epsilon r2, where d and d2 are thickness or distance between two plates is d. మామూలుగా అనుకున్నాం. ఇక్కడ డైఎలక్ట్రిక్ మీడియం thickness d1 and d2, epsilon r1 epsilon r2, like that. This is for n number of mediums. Let us go for another topic. Now capacitance of spherical capacitor. Capacitance of spherical capacitor, parallel plate capacitor we completed. Capacitance of spherical capacitor.